Hello everyone. So, we will start the next segment of the course evaluation of textile material, which is that first segment. It is a sampling method and sample size. In this session, we must understand that what is sampling, what is sample, and why do we want sampling. So, evaluating or estimating attributes or characteristics of the entire system, process or product through a representative sample. The term which is important is representative sample can be more efficient while still providing the required information. Suppose we have a huge quantity of say yarn, say yarn of lakhs of yarn bobbin, thousands of ring bobbins are there. If we want to test all the bobbins, total material for say its count or its strength, it is not feasible. So, we have to select the representative sample to evaluate any attributes, and this if we can sample properly scientifically, this will give sufficient information and which will be actually useful. So, question is that what does sampling mean? So, it is a relatively small fraction of material which is selected from the respective population, and the selection is not random. There are certain process of selection. So, main reason of sampling. So, why do we need sampling? We can go for testing of whole material. If I have one product, one item, I will go for testing, okay, this is okay, this I will test everything, I will try to test everything. But then why do we need sampling? Sampling is required because we do not have a small quantity of sample, we have huge quantity of sample, large quantity of sample, population is a large quantity. So, if we want to test the entire population, then it requires time and we do not have time, we need the result immediately. For example, if we want to know the evenness of yarn, say 30s count yarn, cotton yarn which is being produced in a particular factory of say 1 lakh spindle. So, per day it is producing say more than 1 lakh bobbin, this type of bobbin, and if we want to test the entire population, then it will be time consuming. So, we cannot get result immediately. So, we want result immediately. So, we cannot test the entire population. So, we have to take the small fraction of that. So, time it is related with the cost. So, when it requires manpower, it requires everything, the instrument, number of instrument, power, everything. So, its cost is enhanced. Next reason is that most of the textile materials are testings are the destructive in nature. So, if we keep on destroying the population, then we will not get the material, actual material. So, we have to select the sample. So, these are the two basic reasons for which we have to go for sampling, and sampling is required basically for textile material. It is very important, because textile material it is variable in nature. So, if we see a particular product which is where variation is not there, like one industry who is producing a ball, particular ball, say iron ball, by say certain method, and that there is a fixed system, fixed process, and it will keep on producing the ball of same diameter, same dimension. A rod, an industry is producing a rod, okay, iron rod, it will be having almost same dimension. So, variability is not there. In that case, sampling, although sampling will be required, but it is not that critical. But in textile material, main problem is that most of the textile material, be it fiber, yarn, fabric, wherever it is a variable in nature. You take any characteristics, diameter, it is a variable in diameter, strength it varies from place to place. So, sampling here it is extremely important. Just one small quick example of sampling. Suppose I want to sample 100 gram of cotton from say 10 tons of cotton. So, what is the fraction you are trying to see? So, 1 by 10 to the power 5, that small fraction we are taking for testing. Similarly, say 10 random sample of cones we are trying to take from 15 ton consignment. So, we are taking a small fraction. So, by doing these things we are saving time, saving cost, and we are saving the material also. But the sampling has to be perfect, so that it gives confidence that it is actually indicating the characteristics of the population. So, when the set of all possible items in a population is very large, it may be too costly or too time consuming to do a comprehensive analysis of all the items. So, if you take another example, for example, ring bobbins in a spinning mill, it may be too expensive to test all the bobbins to determine the yarn characteristics, say strength. So, the basic aim of sampling is to produce an unbiased representative of whole population. It should be free from biasness. So, the result of sample may be different from the population, but the sampling should be unbiased. There should not be any, it is a only variation should be in the chance, but none other than that. For example, in cotton fiber sampling from bale, the proportion of fiber length in a sample should be almost same as the proportion in the bulk. Then only we can test the sample for length or diameter. So, if we do the random sampling, so unbiased sampling, then we can tell with certain confidence the proportion, whatever the proportion of length, whatever there in the sample is almost the proportion there in the bulk, in the bell. If we take the sample from the bell or from the bulk at random, from random places, then we can tell. But if we have some biasness, then we will not get this same proportion. Or through sampling system, each fiber in the bell should have equal chance of being chosen for sampling. So, you are giving all the fibers equal chance for to get selected, means if it is a fiber is in the bell form, if the person, testing person goes, he is picking the sample from the surface, from the outside the bell. Now, let us see, suppose this is a bell, okay. Fibers are there, different fibers are there. Now, if the system says that he will only pick the fiber from the surface, then the things will be that if it is known, if it is the standard, then what people will start doing, the fiber manufacturer, okay, fiber supplier, they will do, they will give smaller fiber at the center covered with long fiber. Then we are getting a wrong sample. So, the sampling is telling that there is no biasness. We have to take the sample from everywhere, the chance of sampling is there from everywhere. So, all the fibers from the center of the bell, from the surface of the bell, from the bottom of the bell, there are fibers are they have the equal chance, okay. And for that we have to select some sampling process. The governing factor for sampling is that means what type of sampling will decide, will adopt. It is decided by the form of the material, like whether it is a fiber form, it is a yarn form, or it is a fabric form. Okay. If it is fiber, whether it is a loose fiber or it is a in bale form, or the fiber is from the sliver. So, the sampling method of fiber, so we are taking say fiber, this is the fiber, and here also we are taking fiber, they are the same, it is fiber, but if the form of material, if it is in loose form, the sampling technique will be entirely different from the fibers if it is in the sliver form. Similarly, if you want to test the fiber characteristics from roving which is twisted, so here the testing method will be totally different. So, sampling method. So, sampling method is entirely governed by the form of the material. Suppose we want to test yarn from the bobbin, this is the sampling technique will be different than if we want to test yarn from a fabric. From fabric, if we want to test yarn, say we want to test twist of yarn from fabric, the sampling technique will be entirely different. Next is the nature of material, okay. Nature of material of same form, like as we have discussed the form, whether it is a in the form of bale, in the form of sliver, in the form of yarn, but if it is in the same form like bale, bale in wool and bale in cotton, it is entirely different, because cotton if you open you can take out the fiber, because it is a just compressed, but wool in bale form it is entirely different, because it contains a huge quantity of grease which make it very compact. Okay. So, that fiber sampling from bale of wool is different from fiber sampling of from the bale of cotton. So, from bale of cotton we can pick the fiber by hand, but for wool we cannot do. So, for wool sampling, wool fiber sampling, the system is different, that we will discuss. Okay. Then amount of material available. Suppose I have a material of a container of say 15 ton of yarn. So, thousands of bobbins are cones are available. In that case I will adopt a particular sampling technique, but I have if I have only say 10 bobbins are available, in that case the sampling technique will be different. Okay. Nature of test. So, nature of for based on the nature of test we have to adopt the different sampling techniques, like high volume instrument where you need sufficient quantity of material. Okay. In that case you can actually take different sampling technique. Then if we need say single fiber length measurement, in that case we have to adopt different sampling technique. Type of test instrument. So, whether we are going for a slow method or very fast method or different types of same parameter like again it is a HVI test or it is a comb sorter. So, different types of test method, test instrument we have to sample differently. Information required, for example, say diameter, do you want to measure diameter or we want to measure fiber length. We will see in wool testing one sampling technique is called core sampling technique. In core sampling technique, where a coring tube is there, coring tube penetrate inside the wool bale, where which cuts the wool fiber. So, which cuts the and take the core, take the sample from the inside the bale. Now, once it is cutting the fiber, that means do we want to test, do we test length for that? We will not test. That coring technique is used for either diameter measurement or maybe grease content measurement. If we want to test the length of wool fiber, then it will be sampling technique will be entirely different. Okay. So, what information do we require, based on that we can change the sampling technique. Like twist, if we want to measure the twist, the sampling technique will be entirely different from the if we want to measure the least strength. So, total different sampling technique will be there, okay? Because for twist we need smaller length, for Lee testing we need say 120 yards length. Okay. So, that how we have to change our sampling technique, degree of accuracy required. So, if we think the okay, we want to only know the characteristics, okay, overall characteristics, then our sampling, our number of sample should be will be less. We can have say from a single bobbin we can test just to know the get the idea, but if we want to have certain confidence, say at 99% confidence level or 95% confidence level, we can tell okay, this is the range it is required. Okay. In that case we need a large number of sample. So, sampling technique has to be changed. Then the sampling type is broadly divided into two categories. One is called statistical sampling and next is the non-statistical sampling. Statistical sampling means it is the process sampling technique, these are the techniques where you use bit of statistics, some randomness you use, and non-statistical where we do not need statistical technique. Okay. The statistical sampling again can be subdivided into 4 categories, 4 types. First is called random sampling, then systematic sampling, third one is stratified sampling, which is based on the strata, means subgroup, we are subgrouping that, stratified subgrouping, and fourth one is the cluster sampling. So, and the non-statistical sampling is subdivided into 2 categories. One is called haphazard sampling and then judgmental sampling. So, these are the different types of sampling. We will start with the statistical sampling and statistical random sampling. So, random sampling is based on a random number generation. In this method, each item in the population has the same probability of being selected as a part of sample as any other sample. So, they have the equal opportunity of being selected. Okay. Just for example, a person, testing person could randomly select 20 bobbins. So, his idea is to select 20 bobbins. Okay. To test case of population bobbin within the range of 1 to 1000. So, 1000 bobbins are there, he has to select the only 20 bobbins, okay, to execute some testing. So, how to do that? What he will do? He can use 2 techniques. One is he can use the random number, he can generate random number. So, from 1 to 1000 20 random number can be generated and he picks the sample at 20, but here one has to be very careful that the population is numbered careful, it is randomly, there is no biasness in numbering. So, the lab technician could use a random number generator, or he can simply, one is random number generation, or he can simply put the number 1, 2, 3, 4, 5 and 1000 number he can put in small slip and randomly take like random lottery, and this 1 to 1000 are like 1000 spindles in ring frame. There are 1000 spindles in ring frame and he has generated the random number 20 numbers and he picks the bobbin from all those spindles. And here as it is randomly generated, so all the bobbins they have the equal opportunity. So, that is why how he is using some statistical technique and it is called random sampling. And one advantage is that in random sampling he can use with or without replacement, which means suppose he has to test 5 times and what he is doing. So, with replacement means, so suppose he after random generation he has taken say 51st bobbin, then 92th bobbin, 100 something bobbins, like as such 20 bobbins. Now, with replacement means he will again replace these bobbins to that place, particular their places he will replace, and again he will draw the random number. That means, the same bobbin has got chance of being selected, there is no issue because he is using a random number. So, random sampling can be done with or without replacement, and if he feels this I will not take back all this bobbin. So, that means all 20 numbers whatever he has generated he will discard, he will next sample he will take the replacement sample, he will take the other samples. So, this is done. So, it is if it is done without replacement, an item is not returned to the population again after it is selected, okay? And thus only it can occur only once, okay? So, that is why, but he can it is up to the system, he can do with or without replacement. After random sampling, next is the systematic sampling. Here it is another statistical method. Here the system is that one has to be careful here. In this method, every nth sample, nth element he will take from the list of selected, okay, starting with the sample element n randomly selected from the k element. So, there are k elements, every k elements. So, he will pick nth term. I will give example. If the population has 1000 bobbin, so it has got 1000 bobbin, and ultimately we have to select, our idea is to select say 100 bobbins, 100 bobbins are selected. That means, if you divide 1000 by 100, so k's value is 10. So, 10 every 10th segment, every 10th subgroup he has to pick one sample. So, here k value is 10. So, among 10th, suppose he decides okay, among every 10th 10 bobbin I will select 6th value, 6th bobbin. So, if number 6 which is n is randomly selected from first 10 k value, first 10 elements on the list, the sample would continue down the list selecting the every 6th element from a group of 10th element. That means, what if it is 1 to 1000, he will start taking 6th, 16th, 26th like that. So, this nth term it is actually one can decide randomly. Okay. So, care must be taken when using the systematic sample to ensure that the original population list has not been ordered. So, its population list has to be random, okay, ordered in any way, which actually can introduce non-randomness. So, the original population has to be totally random, there is no biasness. Similar example one can give here, it is a bobbin of 1000 spindles. So, every 6th, 16th, 26th bobbin he can take. Okay. Another example you can see same in a spinning mill, if the auditor of the buying house selects the 14th ring bobbin out of 20th in a random list of all the bobbins, it is randomly so arranged. So, 14th he is trying to, then what are the numbers he will take? First he will take 14th, then he will take 34th, then 54th, 74th in this way. So, after systematic sampling, next is that stratified sampling, which is actually this is the statistical sampling. This sampling is used when representative from each subgroup is known as strata within the population need to be represented in the sample. It is not like random sampling. Random sampling, it may or may not incorporate a particular group, like in an industry who is producing say 30s count yarn from same in a shed, ring frame shed, it has got say 100 ring frame. So, it is producing 30s count, and the ring frame they are from different manufacturer, manufacturer 1, manufacturer 2, 3, 4, say 4, 5 manufacturers. Now, random sampling says that out of 1000 spindle you take random depending on the random number generation. Do not concentrate on the manufacturer A, B, whatever. You can take, if it is coming random number, if you may select the 10 bobbins from a same manufacturer, but stratified sampling says it is not. You first subgroup the make, subgroup the manufacturer first. So, manufacturer 1, manufacturer 2, manufacturer 3, manufacturer 4, and then decide how to take the sample, and you have to take sample from each and every subgroup. Either you decide I will select say 4 subgroups are there and you have to take say 20 bobbins. So, I am deciding okay, I will decide take 5 from each manufacturer, and these 5 when you have selected decided, then you go for random number. But here in stratified sampling, the advantage is that your population, the sample represent the all the make, all the manufacturer. The first step is to divide the population into subgroup. First you have to divide based on mutually exclusive criteria. So, you have to actually decide and you have to mutually understand mutually exclusive criteria, like the make of ring frame in spinning mill producing a same yarn. Now, suppose I am deciding okay, this will be equally, that I have given example, but one can decide in other way. I will give one example, and then random or systematic sample are taken from the each subgroup. Now, example is that if 40 ring bobbins are to be selected. So, I want to select 40 ring bobbins where 10% of ring frames are of make 1, 60% are of make 2, 25% are make 3 and 5% of make 4. 40 you have to take. Now, the mutually agreeable that criteria is that we have to select the bobbin number of bobbins based on the proportion of ring frame. The large proportion will have larger quantity in the sample. So, then in that case 4 bobbins from make 1, because it is a 10% of the bobbin. ring frame. So, 4 bobbins we will take out of 14. So, as it is 60% of make 2. So, then 24 bobbins I will take from there. Okay. Then 10 bobbins from make 3 and 2 bobbins from make 4. So, it takes care of the 40 bobbins, but we may fix other criteria. Okay. All the makes should have equal representation. So, 4 make, 10 from each make, whatever may be the number, I will take 10 from each, so that it is equal. So, it is a mutually agreeable criteria, and then once we decide, then we have to do random selection, like 4 bobbins from make 1. This 4 number of bobbins I may use random numbers, then we will take 24 bobbins from make 2. So, I will use random number to get 24 bobbins. Okay. Stratified sample can also sample an equal number of items from each subgroup, as we have mentioned. Okay. Next is that it is a cluster sampling. It is also known as the block sampling. It is different from the stratified sampling. In cluster sampling, the population that is being sampled is divided into groups called cluster. That means, instead of this subgroup being homogeneous based on a selected criteria, as in stratified sample, the cluster sampling is heterogeneous, as heterogeneous as possible, okay, to match the population. Like there is same make, so 100 ring frame, we make a cluster. Okay. We will test today, we will test from this zone, this cluster, take testing, okay, sample, then and it is next day we can go for in other cluster, and a random sample is then taken like your stratified sampling. Once we have clustered, okay, we have blocked the subgroup, then we can take the random sampling. Just for example, if a spinning mill has 30 ring frames running, the sampling person looking for the testing of yarn linear density might use a cluster sampling to randomly selected 4 those ring frame as a representative, okay. Only 4 he has selected, and then he is taking cluster, he is not taking from all the ring frames for the test, and then randomly select sample from that. This is actually used in spinning industries also. This time he is not taking the entire cluster sampling is very popular, very commonly used here. Okay. Cluster sampling can tell us a lot about the particular cluster, that is a problem here, but unless the clusters are selected randomly. So, we have to again select the cluster randomly, then if it is not done, then it will give us a wrong result. Okay. So, generalization cannot always be made about the entire population. So, cluster sampling is used in various ways, like at different shift people try to, that is it is a cluster. So, at night shift he is trying to take the sample from the night shift production, okay. He is taking and he is testing, that may result in entirely different result than the population. So, cluster sampling they have got drawbacks. So, random sampling from only 4 ring frames or from ring frames of particular make or from product of particular shift may cause bias to the sample, that would not allow statistically valid generalization. So, one cannot generalize, it is a simple one, okay. It is a feasible one, but you cannot generalize. It is not possible sometime to test, suppose a testing person who is working in night shift, he will only test the material at night shift, but it gives certain result, but it is not giving the population, total population. So, that particular cluster, that is for a particular shift, it is giving idea, it is giving that idea of the test result, say strength. But if we want to know the population, then he has to mix all the shift, then cluster sampling is not going to be useful. Okay. And non-statistical sampling, there are two types of non-statistical sampling we have discussed. In non-statistical sampling, the information about the entire population cannot be extrapolated from the sample. So, we get some information which is quick enough, which is easy, very quick, and sometime it is useful, but you cannot extrapolate to the, you cannot predict to the entire population. Suppose what I am doing, I am picking one bobbin from the entire population, I am just going up. I will get some information, okay, this lot is giving yarn strength like that, but I cannot tell with certain confidence that entire population is like that, because I have not done any statistical. Non-statistical sampling are of two types, as I have mentioned, haphazard sampling and judgmental sampling. In haphazard sampling, the samples are selected based on convenience, but preferably should still be chosen at as random as possible. The based on convenience means the tester or person is going and he picks a bobbin from the top of the. This is in textile industry, it is very commonly used, very common, like senior management person, president or some chairman, when he is moving, he would like to know the characteristics of the material. He may ask the person, you pick that bobbin and test and let me know the result. Okay. So, that will give us the quick idea about the product, okay. But we cannot come into any conclusion that because it is not statistically sampled. The example is that a testing person may go to the shop floor and then close his eyes and point at a box containing the ring frame to select a bobbin. Just you take this one, that is the haphazard sampling. That is basically here it is not time consuming, he is going there and picking and immediately he will give you result. He could also grab the bobbin close to him from the bottom or from top or from anywhere. So, that is a haphazard sampling. The advantage is that it is a quicker and use a smaller sample size than sampling technique. So, you can pick okay, 2 bobbins and test it. So, that is the haphazard advantage of that haphazard sampling, and the main disadvantage is that since it is not statistically based, generalization we cannot do about the total population should be made with extreme caution, that is very important. We may tell okay, this is the strength, this is the evenness, but we cannot generalize until and unless we are doing some statistical sampling. It is only for idea. Next is that it is a judgmental sampling. In the judgmental sampling, which is again non-statistical, a person doing the sampling uses his or her knowledge or experience in selecting the sample, it is judgmental. Here suppose a particular in a ring frame shed, a particular ring frame gives problem always, it is suppose maybe due to some humidity problem in that particular portion or maybe due to vibration, it generates high unevenness, high U% because of the vibration in spindle, and after trial, after various your maintenance, this could not be rectified. So, the problem would be that then what he will do, he will try to avoid that sample, he will try to avoid taking sample from that particular ring frame. That is he is using his judgment, so that his sample, his total entire population does not get affected. It is based on his experience. The example is based on the experience, the person may know which type of item are more chance to have non-conformance, what type of item, like product of the night shift, suppose sometime it creates problem, or some product of the say first few lot, first few DOF in the ring frame he is not taking based on this experience, because it will get non-conformance, or which type of item have had problem in past, this type of item had problem, okay, I will not take risk of rejection, I will not take any risk. So, I will just like he will try to take the sample which is bobbin, which is a very good looking, not he is not going to take the damaged bobbin, he is not, he is trying to take fresh look sample. So, that type of sample is he is using his judgment, okay. So, that it is not wrong, it is not wrong, but he is rejecting some non-conformance, basically he is not trying to take any risk, that is the he is using his judgment. Another example is that the sample tester might select bobbin with better appearance, he is always he tries to take, or other sample selector he would like to take, okay, only I will take the problematic one. This is his judgment, okay. And this judgment sampling is important, it happens in actually buying house, in actual trade, like the supplier will always try to use judgmental sampling based on the best quality, he would not take non-conformance, but the customer who will try to see the where is the faulty, where is the fault. Suppose you are sending a consignment to a supplier, he is telling, okay, your sample yarns are rejectable, it is giving a problem. What is the problem? Your samples are, their bobbins are damaged. He will send say 5 to 10 bobbins or package of damaged package, and once you are visiting to his place, it's everything is going all right, because it's a he is using his judgment, wrong judgment, okay. So, it's actually sometime it creates a biasness. So, another way of broad classification of sampling is that one is it is particularly for textile material. Earlier sampling techniques were for general sampling technique, and this technique is for specifically for textile material. One is called numerical sampling. Here in this numerical sampling, a sample in which proportion of all the fibers in sample is exactly equal to the proportion of the population. So, that means it is strictly as per set norms we have to take that sampling, that which means that if you take out, if you remove one sample, the rest population, the proportion of the fiber length will not get affected, that is called the numerical sampling. I will give example subsequently, okay. And next is the biased sampling. bias sampling, it is basically in textile, in a fiber it is called length bias sampling. In bias sampling, when the selection is influenced by factors other than chance, that is called bias sampling. A sample ceases to be truly representative of the bulk and a bias sample result. So, bias sample is actually here where it is not due to the chance factor, the variability is due to something else. Okay. Now, let us see what are the different causes of biasness. Biasness can happen due to various reasons. The causes of biasness is that bias due to physical characteristics. As I have already mentioned, the longer fiber will have always greater chance to be selected, because it has got higher surface area. So, in this sliver it has got long fiber or short fibers mixed, but if I am trying to pick the fibers, higher probability will be there that longer fibers are selected, because it is a more higher area, okay, higher projection. Next is that causes of biasness is that position relative to the person who is selecting, who is taking the bias sample. The lab assistant may pick bobbin from the top or may pick bobbin from which is close to him. So, that is a cause, one cause of biasness. Third cause is that subconscious biasness, that I have already mentioned, which is the haphazard or this type of sampling. Subconscious biasness, we have tendency to pick the best looking item and free from any damage, that type of sample we are taking. That means, we are introducing biasness, we are trying to get the best result, that is the. And also I have already mentioned, sometime it is a conscious biasness is there. As a supplier, you are trying to project your product is best quality. As a customer, I am trying to project that your material which is worst. So, that type of conscious biasness is also persists, but it is not that important. These are the causes of biasness. Next class we will continue with this sampling. Okay. Till then, okay, goodbye.